Welcome everybody. This is Bob Buckheim here. You see Stella Kafka, the AAVSO Executive Director, and Gordon Myers, the AAVSO President, and Bob Stevens, the AAVSO Treasurer, as well as Jerry Foote, Bob Gill. Oh, and Wayne Green doesn't get in because we ran out of video slots, but Wayne Green is also here. And I welcome all 100+ of you to the episode 4 of the online SAS-AAVSO Symposium this year. Well, I thought it worked. For those few of you who may not know AAVSO and SAS, I encourage you to check out the websites to learn more about what these two fine organizations do and offer to you. Also, most of you are now trained professionals in how GoToWebinar works, but I know we've had a continual stream of new registrations over the past week. You should see on your upper right side of your screen a little control panel like the one shown here. The way you interact with the presenters and the staff is either click the raise hand button, in which case we will know that you have a question or comment, or you can go down to the questions box and type a question in there. Wayne and Jerry will be monitoring both of those during the presentations, and when the Q&A time comes, you will be recognized. We will either unmute your mic so you can ask your question, or Wayne will read the typed question to the speakers so that we'll have a sort of a two-way communication here. Reminder, the session is being recorded and will eventually be publicly released. Thanks very much to the SAS production team who have pulled these webinars together. Bob Gill is handling the slides. Jerry Foote and Wayne Green are handling the Q&A. Jerry is also the master of ceremonies. What that means to the presenters is he is indeed the man with the hook who can pull them off when the time comes. He'll show the 5-minute warning, or for the poster papers, a shorter warning, and we will try to stay roughly on schedule as a result. Let me thank our sponsors, DC3 Dreams, Software BIS, whom you will hear from later in this webinar, Sky and Telescope, Woodland Hills Camera and Telescopes, Field Tested Systems, Optech, Observatory Operators, Hyperion, Planewave Instruments, and Starlight Express have all been loyal supporters of the SAS Symposium. We encourage you, when it's time to add to your observing kit, to take a look at the fine products that these sponsors and vendors have on offer for you. We have attendees literally from all around the world. I show 123 online right now. Let me hand over to Stella Kafka, since the star of the show during the first portion of today's session is the AAVSO. Stella?
Wonderful. Thank you, Bob, and welcome to everyone who is joining us from near or far. As Bob Buckheim mentioned, who, by the way, is one of our board members, this is going to be more of an AAVSO focused 1 hour. I mentioned during my introduction, oh my goodness, it's been 3 weeks ago on our first episode, that the AAVSO is going through a strategic planning process. We are working with our board. We have been working with external partners to overview our portfolio and see where we're going in the future. So during this meeting, I'm going to actually hand it off to our president, the board president, Gordon Myers, who is going to give you an update of what has been happening at the AAVSO, all the exciting new initiatives that are happening around the strategic planning are some of the decisions. And we're welcoming questions from you. Please keep in mind that this is not completed yet. This is work in progress. So Gordon's going to tell you more or less an update of where we are, where we're standing. So I don't want to take more of his time. Gordon's all yours.
Okay, it's great being here. My thanks to Bob Buckheim and the entire SAS team. They've been doing a phenomenal job getting us up and operational. Let me start by really just talking about first what I would like to cover today. Here's the agenda, really giving you an idea of what we're trying to accomplish with the strategic plan. Going through a lot of the ideas or conclusions, or many of them have already started, and I won't talk through those. Then I'll talk about what's ahead of us. A little bit different than other presentations. We're going to break a couple of times during this to take questions rather than holding all the questions to the end. We thought that might help things flow smoothly. So about a third of the way through, or we'll have like a 5-minute break and take any questions, and then continue on, and then close to the end do another break, and then at the end have a final discussion with questions. So let me start with why are we doing this plan? And I think the simplest way to say it is our organization has been active for over 109 years now, and is continuing to do very well, but we also see that the world around us has changed, and there are a lot of new opportunities as we go forward that we want to take advantage of. And we really focus on 3 primary objectives. I consider this the 3-legged stool that keeps the organization successful. One is we want to achieve high membership satisfaction. I mean, that's why people belong to the organization. They enjoy what they do. They enjoy their interests, their hobbies. They like to work with other people who have similar interests. They like to have a place to go to share ideas, to learn, and have a home. And that's what we are. But we want to ensure high membership satisfaction. The second leg of the stool is the impact of the organization. And you think about that certainly in terms of the professional connection we've had for our entire history. We want to continue that and expand it. But secondly, in addition to just the professional impact, there's what I call the general public astronomy interested community. Those are people we want to reach out to. We want to bring them into the organization. We want to share the fun and excitement of actually doing astronomy, not just reading about it. And that's one of the key elements of the impact from the organization. And finally, the obvious third leg is money. Do we have a stable financial plan? How do we spend the money we have? There are a lot of new ideas where people would like to do other things that would require additional funding. What can we do to increase the funding? So I'll go through those 3 major sections. Quickly, in terms of who's done this plan, there's been extensive involvement of the whole AAVSO board, extensive involvement of the staff. We were fortunate enough, as some of you know from last year's discussion or last fall's discussion, to have been selected by a nonprofit group in Boston called the Harvard Business School Community Action Program. We refer to it as CAP. You'll see the names of 7 individuals there. I'm not going to go through them, but I will tell you they have each, and I'm not exaggerating, they have each spent hundreds of hours over the last 9 months working with us, talking with our members, talking with others, getting ideas, and giving us advice. It's been a very, very valuable exercise. In terms of how we do this, I guess I would just use one word to say the most important part of doing this plan was listening. It was hearing what you all want. It was hearing what the professionals tell us about ourselves. It was hearing from the general community interested in astronomy, what they would like to see AAVSO doing. So it was very broad-based. As Stella said, we're not finished. What you're going to see right now is an interim report. We'll give you ideas of the things that have already changed, other things we're looking at. The final plan will be presented in November at our November meeting. So I'm going to go down the 3 legs of the stool for a minute in terms of what we're trying to accomplish. On membership satisfaction, there's several things that we have already done to, we believe, really meet the needs and the interests of our members. I think the one that is most visible to people is what is going on with our sections. We've really re-energized all of the section activity. Sections now have members. Now, I always think that may sound funny, but up until recently, you could join a section forum, but nobody had a list of even who was in that forum to talk to. So the section leader, the only way they could get to the members was through posting on the forum. What we want to do, and what we have done, is now you actually join a section. We want to have a group of people who can get to know each other. Part of this organization's success and membership satisfaction is camaraderie, feeling about that. So we've actively organized the sections. Second, and I think most important, Bert, Stella are leading meetings of these section leaders. They get together, they talk about what works, what their members are interested in, they share good ideas. One of the greatest ideas that started a few weeks ago, I can't remember the exact date, a month ago, we did a trial, I think it was the extended binary section, a trial Zoom meeting of that section. I think that we only posted it on the website for 2 days, and over 30 people showed up for like what ended up being a 2-hour discussion. So we decided we're going to have a webinar series starting next week, actually, with each of the sections. And I will tell you, Stella sent me a note yesterday. We just put this on the website within the last, I think, 3 days. We already have 90 people who have signed up for the first webinar, and we have 50 people who've signed up for the second and the third, and that's all we're allowing registration for so far. So there's clearly an interest, and clearly, I guess if there's one good thing coming out of coronavirus, we're all learning how to do these things online and work together remotely. And I think for AAVSO and our members, that's actually going to be a real benefit so that people can be part of a shared community. Another item in terms of sections, if you go back a year ago, some of you who were at the SAS meeting a year ago, I know I was there, and we had started the strategic plan process, and we were talking to a lot of members. Many of them said, you know, we're really interested in the, I'll call it the engineering side, the instrumentation, the equipment. How does that work? That is the fun and enjoyment they have. And they wanted us to create a new equipment and instrumentation section. And we have done that. Richard Berry, who many of you know from AIP for Wind fame, and also he's their second vice president, very active in the astronomy community for years. He is leading that section, and he has really, I think, already has a cadre of some of our best experts in this area who are going to be supporting him. So if that's your particular interest, that's a place for you to really find a home. Other quick things, we're working on getting more and more involvement with professionals, giving us feedback, talking to us about what's happening. They ask for data. We'd like to be sure they tell our members what's going on. There's a lot of focus on that, and we're bringing sections leaders in, working with Elizabeth, working with the staff, really getting more initiatives started for each of the sections. And finally, we're working on the website, so you can get more information about the sections through the website. So this is really a key step forward. Here are the observing sections. This is a list hopefully most of you have seen before. It's bright star monitors, cataclysmic variables, eclipsing binaries, exoplanets, high energy network, instruments and equipment, the new one, long period variables, short period pulsating variables, solar, spectroscopy, young stellar objects. Each of these have a leader. You'll see the names of the leaders of each of those sections, or the co-leaders. I think this is a place for you all to find a home if you're really into observing and getting to know people who have a similar interest. And here's the webinar schedule. I'm not going to go through it, but you can see that starts with the Bright Star Monitor session literally a week from today and goes on through the middle of September. Okay, what else? How else can we satisfy our members? What else can we do to improve what we're doing today? The IT system, you know, the IT system, it's a core of what we are. Cap kept making the comment, data is the core of the organization. That is where the family jewels are. And one of the things that came up really started almost, I think, 2 years ago. There were concerns about the website. There were concerns in terms of security, access, stability. We were on outdated platforms, and there's been a lot of work going on for the last couple of years that is targeted to complete by year end. We hope it will be done prior to the November meeting. But to get us, for those of you familiar with the term, from Drupal 7 to Drupal 8 was one of the infrastructure items, which has been a non-trivial change, getting from Python 2 to Python 3. There's details that have been done to improve it. And you'll also see some changes on the high level menu. It's not a total rewrite of the website, but some of the high level menus so that when people come to the website, it's more welcoming. We think it will help us attract more new members. And things like the database strengthening, being sure that we've got the backups, so the pragmatics have been reinforced as we've gone through this. But what else? These tools are critical to our future. These tools are critical to our members. Many of these tools people download to their PCs and they use them operationally. And we need to be sure that we have an overall plan for how they work together, when upgrades need to be made, how we will coordinate upgrades across the different tools. We haven't really had a straightforward way to kind of oversee and guide that. I'm going to have an IT committee to help us look at all those tools, look at what needs to be done, coordinate plans, and move us forward. In the long haul, there are a lot of people who would love to see us, totally redesign the website, go to a 21st century design. And that is something I think we would all like to do someday. I think that's, as we have looked at it, not inexpensive. It's something that'll be down the road. That's something we have on the back burner. What else? How else do we satisfy our members? I mentioned earlier, feedback from professionals. I can't tell you the number of times members have walked up to me and said, can't we get more feedback to know how the observations were used? And when feedback comes, the members are, hey, it was really neat seeing how the data was used. And I felt, satisfied because I was really more part of that project. So there's a lot of discussion going on with the professionals. And on the flip side, we'd like to get more professionals working with us. And one of the things that we realized was that many professionals said there are a lot of professionals who don't know AAVSO is here. They don't know the quality of the data they can provide. So we're working on that outreach, the marketing to professional side, being sure they know what AAVSO does. Another item, data mining. Everybody's talking data mining, given whether it's light pollution or technology or whatever, right? And we're starting two initiatives right now. One's already active with VSX. If you're into data mining, you can go to the website and get information and help us look at making some of the information in VSX more accurate and really improving what's in there. Secondly, a lot of people have talked about working with data from satellites. So we're putting together a workshop. The test satellite, as I think a lot of you know, is primarily focused on exoplanets, but it provides a lot of data and information that can be used to study variable stars. So we're going to have a workshop at the fall meeting to show members how they could actually access that data and do research pulling data from there. Another one is AAVSOnet, and there's been a lot of work, the tremendous teamwork on this, improving the stability. It's not perfect yet, but it's very good. And I think that we're going to tie that to specific projects as we go forward. Lots of other things are coming up. I won't go through this list, but you just read down it. There are many, many ideas for how we can reach out to our members and provide additional things that they would like to see us focus on. Let me stop there for just a minute and see if there are any questions about what we're doing in terms of this initial leg of the stool. If it's silence, I can go on. Do we have anything yet? I don't know how to tell here.
I'm not getting any typed questions. Let's see if there are any raised hands up here. Don't see any raised hands.
Okay.
Very good, Gordon.
Okay. So, by the way, this is a photograph. Think about this for a minute. This was last November, right? Pre-coronavirus. I wonder how long it will be before we will have a photograph of all of us at a meeting not wearing masks. we will hope that comes sooner, not later. Increasing the impact of the organization. Certainly, a lot of what we do has had impact for our entire history of working with professionals in advancing the science of astrophysics. It's a wonderful history, and it's really a marvelous history. So if you look at that and you look at the items I just went through in terms of where we're doing new things to work with members, all of that has an impact on the research in the astrophysics world. But beyond just working with professionals, I mean, I'll be very honest with you. I've had some members say, you know, that's not why I joined AAVSO. I joined it because I wanted to learn more about telescopes and technology. I joined it because I just wanted to learn more about astronomy. I just want a place to find other people who are interested in the same things I'm interested in. And this second bullet, I think, is really key. We want to attract new people to the study of variable stars. We are not a general astronomy education organization. That is not who we are. What we are is people who really do astronomy. They're not, and I don't mean it in a pejorative way, we're not just armchair astronomers. We're people who like to pull their telescope out or put the binoculars to their eyes or just look at the naked sky, or many members have their own observatories. We have a wide range of capabilities, but they're people who want to personally be involved in astronomy. And I think there are a lot more of those people out there than we currently have as members. It was interesting to me in the meet and greet session that we just had before this meeting, and I was only able to stick around for the first half of it, but it was interesting that there were many educators. There are people who work with AAVSO to create projects that they use with students. And I think, it's an avenue of activity that a lot of members would like to be part of. We also, we've talked about expanding our membership and bringing in more young people, bringing in more women, being more diverse. And all of those things are things that it's not that we need to do them just because it's something to do. It's because it brings us a broader set of membership with new ideas. It's been interesting to me in this meeting, the SAS-AAVSO meeting, how many student presentations have been given and the quality of those presentations. It's to me, very exciting. I think, one of the things I was going to comment later, but I'll make the comment now. I think when we started this strategic plan, one of the questions we were seriously asking ourselves is, are there any young people out there anymore who care about astronomy? Are there any people who, like many of us, thought this was a fun thing to do when we were younger? And the answer is yes. I mean, we've seen that because you see presentations like we've seen here. We've seen that in talking with other people over the last year and a half, but they don't know we're here. We haven't gotten our word out successfully. So CAP, the Harvard group, kept harping on us, if I can use that word. We don't market ourselves successfully. We don't get the word out to what we do, whether it's to the broader, what I call the general public with astronomy interest community, or whether it's even to professionals. So there's a lot to do on the marketing side that I think can help us grow, help us diversify, and I think in the long haul significantly increase the number of active members, which in turn increases the impact of the organization. Another item in terms of increasing the organization impact that we need to work on. These are things we know we need to do. We don't have plans in place yet, but new members, when we talk to people about what it was like when they joined and why have they struggled, many of us have been doing this so long that we forget what we didn't used to know. And we don't have a graceful way to bring new members on to climb that first wall of understanding how to do variable star astronomy and what opportunities there are for them to get personally involved. So we wanted to develop some new programs and ideas around that again will expand our membership and increase our impact. The mentoring program is one that has been reasonably successful. Maybe I'd say partially. I've been one of those people, so I could, look in a mirror, so to speak, on this and say there are ways it can be done better. But I think we also have members who can help new people learn more and do more, and we want to figure out a way to enhance how we work with new members and mentor them. CAP, during their discussions with us, one of the things they talked about was mission statement. Now, I will be honest and tell you, talking about mission statements will sometimes make up my eyes roll backwards. I mean, it's not necessarily the most critical thing. And then I'll add the word maybe, because what CAP highlighted for us is that if we can't crisply describe what we are all about and what our objectives are, we're going to have a difficult time getting funding from other organizations and from expanding the number of members we have. So we're going to spend some time and clarify that as we go forward. And another thing you're going to hear a lot more about as we go over the next 6 months, as I think many of you know, we have a new editor for the SAS-AAVSO. And Nancy has a lot of ideas about how that can be improved, how it can be leveraged, how it can, I think, do two things. It provides opportunity for members to publish their works and their activity. And on the reverse side, it's a source of information and knowledge to help people be more successful in terms of what they are doing. It's a great place to learn. Now, when we talk about impact, and I wasn't even sure where to put this discussion of volunteers, but it's really an important discussion because it affects multiple things. It affects our impact, it affects membership enjoyment of what they're doing, and it affects the cost and finances of the organization. So this affects everything that AAVSO does. I was actually surprised. I knew we had a lot of active volunteers, but we hadn't until now kind of put them all on one chart and said, how many active volunteers do we have? The answer is roughly 100. This isn't 5 or 10 or 15. This is 100 people in our organization who actively spend a lot of their time volunteering at AAVSO. There are the list. There are the 11 different teams that they are members of. And, I could pick any of those teams and get some of those members to talk and describe what they're doing. There is a huge amount of work going on that the volunteers do. And one of the questions, CAP asked us as we were going through this was, have you talked to your volunteers to find out, are they happy? Okay, gee, we hadn't done that, to be honest with you. We had anecdotal one-on-ones, but we hadn't done a coordinated review. So they did a survey and they sent out, I can't remember the exact numbers, I think right around 100 surveys. And within, I think, 3 days, they got 50 back. Well, that startled them because they said you don't ever usually get that kind of response on a survey request. But more important than that was when they analyzed the results, virtually all of the volunteers expressed deep satisfaction and enjoyment in what they were doing because they felt they were making a difference and they also felt they were learning more themselves. And I wanted to bring it up here because I think volunteer activity as we go forward, I know we will come back by the time we get to November. with some specific areas where there are additional volunteer opportunities. And I think it will give all of our members a chance to, not everybody wants to be a volunteer, and well, not everybody wants to be a volunteer, and that's fine. But for those who do, there's some real opportunities to really learn more and to help the organization grow. And you'll see, like I said, you'll see more of that when we get to November. Okay, the third leg of the stool, finances. This is like anybody trying to look at their own personal finances, right? What do you do? What's my income? What's my outgo? Where am I spending money? What do I want to spend it on? And how do I make the amount of money balance with all the wonderful things I would like to do in life? I mean, that's how you do a financial plan, right? So first, a little bit of history. Where are we now and what's the history? Well, most of you know, and if you don't know this name, it's one you should have in your memory bank somewhere. Clinton Ford was a member of this organization starting in, I can't tell you what year, in the I think 1950s, maybe even 1940s. And he started as a high school kid, observing variable stars. And he became quite wealthy. And that was, I think he was an investment manager. He was not a professional astronomer, but he loved astronomy. And for years, and I can't tell you exactly how long, I'm sure there's some members who might know, but kind of at the end of each year, the executive director would call Clinton and say, well, we overspent our, the money we've received by, pick a number, a couple $100K, 100, whatever, and he would write a check. And for quite a few years, literally, he was balancing the budget of AAVSO with a year-end check. And when he passed away in the early 1990s, he left a large bequest to the organization. And that bequest really has built the vast majority, not all, because other people have donated money also, but it's really been the core of the endowment that has funded a lot of AAVSO activity for the last, 25, 30 years. So what does our budget look like? These are round numbers, don't try and nail me down on the precise numbers. I'm trying to give you a big picture view of the financial situation. Roughly 70 to 75% of our money we spend each year and have spent each year for years has come from the endowment. CAP made the comment they've never seen an organization with that high a dependence on the endowment. One of their recommendations you'll see is we need to look to ways to reduce that. Well, where else did the money come from? Well, roughly 10% from membership dues, another 5% from member donations, and the other 10% kind of varies from year to year. Sometimes we have a grant, sometimes we get a bequest, sometimes there's a one-time donation a person or people give. We get smaller amounts from our choice courses, our sponsors, and meetings. And that kind of what pulls it together. Now, as I'll show in a minute, kind of what's happened with the endowment over years, but clearly this has not been a good year for the stock market. The 2020 coronavirus market meltdown hit us like it hit everybody else, and we've climbed back, I'm going to say halfway, some number like that. But it also has affected the finances as we look forward. But this chart, and this is a CAP chart to drive home a key point. If you look at the endowment, really all of our assets back in 2004, so less than 20 years ago, we had roughly $15 million. Go to the right bar, what do we have today? Well, this 13.3 was really at the market low. The number now is, I don't know, between 14 and 15. And it varies daily with the stock market's gyrating. So, but it's in the neighborhood of 14 to 15 million right now. So the dollar amount is roughly the same. But inflation, well, it's been low, 2% a year. Well, 2% times 16 years, and we've lost roughly a third of the purchasing power of we have in the endowment. So this is one of the reasons that we've been challenged. We've been challenged over the last few years. This isn't new news. It's just the reality that if we can't continue to do things as we've cut the staff back multiple times in the last few years. And I know that's been a frustration for some members, but we've had to live within the money we had, and it's still the curve is headed down. Now, CAP created two other charts, and they did this kind of looking at how the amount of money we're currently spending with the current set of activities. And kind of they created what they called the status quo. And the status quo is kind of keep doing what we're doing, spending the same amount of money, withdrawing the same percentage from the endowment, keeping the staff as it is, keeping the current programs, not adding new programs, is status quo. And with that, the point they've made is the curve is going down, especially when you lay in the effects of inflation, and that we really need to do and focus on this so we can turn it around now. While it's not a crisis, this is not a crisis du jour. It's not today's crisis, but it is a financial situation that we need to turn around as we go forward. So they came up with a set of suggestions, and I won't go through the details of those. I'll hit some of the highlights, but it's, this looks like the inverse of the coronavirus goal curve, right? We now want this to go up. We want this to figure out how we can put together a strategy and a plan that turns the financial situation around. Well, how do you get there? This is high level, but I think it will bring the point to a head. One is when they looked at the endowment manager we've had, they felt that they were good but not great, and that we might want to assess going with a different company to manage our endowment. They felt the fees were a little high, and they felt some of the judgment was not necessarily the best. So I want to give Dick Post and the Finance Committee kudos for this. They, over the last 4 months or 5 months, went out, talked to, I think it was eight different potential investment company managers, went through detailed discussions, and I'll just summarize the net is that literally last week, the board approved the Finance Committee or the Investment Committee recommendation, and we switched to a company by the name of Alex Brown, which is a subsidiary of Raymond James. And we feel that this will ensure that the endowment is managed in the most effective way. The second item is, in my mind, almost the toughest one, because it's not that we haven't been trying to raise more money. It's that honestly, we haven't been particularly successful. And Stella was successful this year in getting a significant NSF grant for the workshop. But overall, this has been a challenge for the board, and a challenge for everybody. And CAP gave us some constructive criticism. And basically the constructive criticism was you have to stop thinking like amateur investment managers and amateur fundraisers. You need to get some professionals involved in the fundraising strategy. You need to have people work with you to identify what organizations you can go to seek grants. You need to have people get with you who know how to talk and find the people who are interested in astronomy. And then this is not, their repeated point was it takes time to develop major donors. Very few people are going to write you a big check because you go in and make a one-day presentation or a 2-hour presentation saying, aren't we great and aren't we beautiful and we do all good stuff. That's not the way the world works, right? People want to get to know the organization. They want to know whether the organization is doing good work. They want, in many cases, they want to personally get involved. So there's a process that you constructively go through and actively go through in order to really put the organization in a position to get major donations. So we will, and this is, we have to fit this into our budget. We're not going to hire a full-time fundraiser. That is something that people who've been in this world will tell you not to do because the odds of landing on the perfect person are usually close to zero. But rather, CAP has connected us with some consultants who can work with us, and we'll be working with them to put together a true fundraising marketing plan and give us specific ideas on how we can cultivate major donors. So a lot of work to do here. But as I'll say at the very end of the discussion this morning, I'm really optimistic about this. So what else do you do? One, you always go back and say, can I cut expenses? And kind of the way we're looking at this right now, where can I free up some resources or some of the people we have to do other things that may be higher priority? And we're working our way through that. And I would say what those who know me tend to know I can be fairly blunt, so I'll be blunt now. We're going to have to stop some of the programs that some people love, that are lower priority, and we're going to enable us to start the programs that we think are more important. I'm not announcing any huge cuts right now in terms of programs. I'm just saying that there will be some adjustments, and no matter what we touch, somebody may be, not happy with that. That's just the reality. But I think we're going to come out of this with a very good plan for what are the major focus areas for the organization, where do we need to prioritize our spending and the use of the people and the money we have. And finally, we're looking at the real estate alternatives, lease, rent, what do we do with the building? This is another one of those subjects that can key off a lot of almost emotional reaction that we don't know. We have not made any decisions yet, but we want to understand, what the best use of the organization, the facilities are, the real estate. And I think very honestly, the whole world coming out of coronavirus is going to be reevaluating work environments. I think that more people will be working more from home. Well, how does that affect our real estate needs? We don't know. We're obviously experimenting with it right now because it's been forced upon us. But we really want to step back, look at the real estate, make a decision. What is the right thing to do with what we have? So, having now hit that one, are there any questions on that? I figured finance might kick some unique questions, but maybe not. Nobody's raising their hand or asking questions.
I'm not seeing too many raised hands. This is an awfully long list. But we have a raised hand here from Ed Wiley. Ed, I'm going to go ahead and open your microphone up. There you go, Ed. Are you with us?
Yes, I am. I wanted to go back to the educational aspect. So if it'd be better for me to hold my question until the general discussion, I don't have one on finances. I do have one on some suggestions on the educational outreach and the second part of the leg.
Okay. Let me go ahead and wrap it up. Let me go ahead and wrap it up then, and we'll just do questions at the end. We've got some noise on the mic. There we go. Let me just say what's going to be. That'll leave 10 or 15 minutes for questions at the end. Let me just kind of highlight, first of all, what we come out of this. So what's changed? I mean, if I'm a member, like, great, we did a strategic plan. So what? Okay, what's changed? Well, I'm hoping that what you see is that AAVSO is providing you more opportunities to be involved, and that you are enjoying being a member of a community. That this is something that is fun. This is something you like participating in. That you're getting the kind of information, the training you need. That there are people of shared interest. That we've started some new initiatives that are of interest to you, that make it even more enjoyable. I also hope that, as I talked about volunteers earlier, that volunteers, to me, it's well, as I said earlier, it's all three legs of the stool. It's enjoyment. I was impressed, as I mentioned earlier, by the number of volunteers we have, by their satisfaction, by their feeling that they are accomplishing something and contributing. And the inverse, so that certainly then is all the things, all the people they affect because of what they've done and how they volunteer. So there's that secondary effect. And they also learn a lot in being volunteers. And it also helps financially. Financially is the wrong word. It helps us do more things. It helps us do things that we don't have the money to do, but the members want to do. And the volunteers enable us to accomplish those new initiatives and do those things. So what's going to happen as we go forward? Well, we're going to work our way from now to November, the board creating a more detailed plan, both balancing the interests and desires of the membership with the money we have, with the number of volunteers we have. I don't see this as a one-year plan. I think it's going to be a 1 or 2 year transition just going through this. So we're going to do a multi-year plan. I think the first year is obviously most critical, but we have to have a picture of where we expect year 2 and year 3 to go. We will present that to the organization in November. And then really what I call the hard work starts. Do it, right? Don't just talk about it. I say this too often, but talk is cheap. We've got to get on with having a plan of how this is going to happen, and then we need to go execute that plan. Now, let me close with, I'll jump up to 50,000 feet or maybe go to the moon's altitude, I don't know. But I'm just going to go to a high level for a minute and just talk about the future and kind of my views of what we have learned in the last year and a half. I don't know if you remember, but when we've talked at the previous meeting, when we started the strategic plan, there was first a question, is AAVSO even relevant? Has the world of satellite telescopes, has the world of space telescopes, has the world of all sky surveys kind of made this whole effort of amateurs, worthless? And I will tell you that, as I've said before in the last meeting, we found the exact reverse, which I think actually surprised us at one level, in that the volume of data is swamping professionals, and the type of data that is being gathered can't do what amateurs can do with their individual scopes. So there is a huge need on the professional side for what we're doing. Now, what else is going on? Well, from what we did 109 years ago, been a little change in both the understanding of astrophysics and the technology available to amateurs, right? I mean, it's kind of, every time you really sit down and make yourself think about that, it's pretty stunning for what's happened in the last 109 years. Whoever thought amateurs would do spectroscopy, whoever thought amateurs would have telescopes getting 17th, 18th, 19th magnitude observations, whoever thought we could do the kinds of things that we do today. The whole field of data mining, just brand new opportunities where people, they don't have to have a clear sky. They don't have to have thousands of dollars sitting, available to them to go out and purchase their own telescopes and have their own observatories. There are things that a very broad set of people can do. And as I mentioned earlier, my concern and are there any young people who really like to do this anymore? Yep, the answer is yes, there are. So when I sit back and look at AAVSO and I say, okay, what is our opportunity, not just to maintain ourselves, but to grow, become larger, increase the impact of the organization, have the financial resources we want, have greater impact on professionals? There are just a huge number of opportunities. I mean, to me, it's very exciting. And I think, we need to figure out how to balance the finances. We have a lot of work to do, but on the other hand, I think I would just close. I'm not being Pollyannish. I just want to say I genuinely believe that the future is both extremely bright and there's a lot of opportunity for moving ahead. So let me stop there. Have about 10 minutes left and see if there are any questions people would like to discuss. Maybe Ed, go to Ed first and let him bring up his question.
Okay, Ed, I'm opening your mic up. How are you doing?
Good.
I'm doing good. Gordon, first, thank you very much for a really informative talk. I really enjoyed it. I don't know if any of you have ever heard of Emporia State University, but they put a little thing called the Kansas School Naturalists together that goes to about 2,500 high school biology. How they finance it, I'm not sure, but it's activities like that could really make an impact on the educational community, knowing about AAVSO and its mission. You could call it AAVSO School of Astronomers or something like that. So that's one thing that I thought of. The other thing I thought of was, as I'm thinking about Russ Genet and his work with high school and junior college students, he puts up programs where at the end of it, the students write a paper. And I'm sorry for this phone I've got, if you can hear it. Sorry. So there are three ingredients that go into that. One is teaching the students to do a research project. Second is picking a research project that's publishable. Third is having a journal and a friendly editor who's willing to take high school and junior college student papers. As a professional educator myself, working with up to PhD students, I found that the very best prediction of how well a student is going to do is whether or not they have participated in research and published a paper. And so I would suggest that AAVSO think about how to gather these people into these student research projects, not as a lab experiment, but as a publishable paper with their name on it. Because once you hook them that way, they tend to be hooked.
Right.
Thank you very much.
No, that's a good idea. We'll follow up on that. I think this whole avenue of working with the education community might be very, very both productive, enjoyable, and potentially a source of some grants and donations.
Yeah, and grants. We live on grants. I'm glad to see you've got professional grant writer people into the long range plan, because that's the only way you're going to get out of eventually spending your entire endowment.
Yep, I agree. Any other questions people have?
Yeah, we have a couple coming in here. Gary Sivakov had his hand raised. Gary, I'm going to open your microphone up. There you go. You with us?
I hope mine's closed.
Gary?
Okay, Ed's was closed now. Thank you. Gary doesn't seem, I keep pushing on the button and it keeps turning red again. Can't get him to open. Gary, if you could type it into the question.
I think
There
I
we
just
go.
Okay, this is Greg Sivakov. I was just actually trying to point out that there was a question and answer that was answered from the SAS perspective, but it might also need to be addressed from the AAVSO perspective. And so I'll read it. It's, unless I buy a transatlantic flight ticket, I cannot physically attend AAVSO meetings. After the coronavirus crisis is over, will there still be focus on online webinars or meetings?
The answer is, well, go ahead, Stella. You want to answer that? So.
The answer is that we will definitely consider ways of bringing together our international community. We do understand that the in-person meetings are not exactly the most efficient way of bringing people from all sides of the world. So moving forward, the vision, the proposal is to do a hybrid model of both, more or less. We're learning a lot about online meetings. We're going to learn a lot moving forward with the science fair, the observing section webinar that we are starting, we're launching next week. So please bear with us and give us as much feedback as you can. So how to improve those. I would really like to see this kind of initiative continuing. And I'm pretty sure that the board is in agreement with me when I'm saying that we're trying to build communities. So we're trying to make our resources and our communities accessible all over the world. So stay tuned. That's my answer.
We have a few more questions coming up. Kaylee, Kali, I'm going to go ahead. This is Kali Talk. I'm going to open your microphone up. Kali, are you there?
Hi, Kali. Where's she?
Kali, you're open mic at the moment? You're like a radio guy. I'll go ahead and read her question. She says she works with Russ Janae, and was looking to jump in. We'll get back to you here in a moment. Michael Miller has raised his hand. Michael, I've just opened your microphone. We're having some kind of interesting stuff there.
Can you please type your questions? I think it's much better. There's lots of feedback here.
Okay. Mike Hoffert has raised his hand. Mike, I've opened your microphone.
Yes. Gordon, this is for you. This is a money question. What kind of financial return do you really need to actually grow the AAVSO according to your future plans? You know, what do you need per year? Because
Yeah, no, it's a good question. And I will tell you, because I've been part of discussions on this for many different organizations for the last 10 or 15 years. Kind of the general guidance is you need, if you want to grow with inflation, you probably need at least, you shouldn't withdraw. You have to look at it through those ways. You shouldn't withdraw more than like 4.5%. If you get up into the 5% range, you might be able to stay flat, maybe not. If you go above 5%, you're probably going to slowly erode the absolute value. So right. It's in those range. And I've been with organizations that have taken between 3 and 6, and you know, and again, it's a prediction of the future, but that's based upon the 100 years of analysis of the stock market returns.
Right.
And I can partially answer that. The CAP models that you saw, a brief summary of, they were predicated on a return in the market of 5.25% in the near term. That plus other things like raising, you know, grant monies and stuff like that is what will allow us to bend the curve.
Mm-hmm. Good. Good, and you aren't taking like a lot of risk there. Thank you.
Yeah, I mean, in general, what's the standard model? Most organizations, 60-40 equity, you know, fixed income. You know, we're in that range. We'll have to see what our new manager recommends.
Okay. Richard Stanton has raised his hand. So Richard, I'm going to go ahead and open your microphone up. Oh, missed. Okay. I'm having a little bit of trouble here because my list keeps jumping around on me. I'm sorry about that, guys. I have no idea what's going on at the moment. Richard, your mic is actually open.
Rich, are you talking?
Not.
Maybe with Stella suggest if you can type the question in.
Yeah, I'm afraid we're going to have to go to typing some questions. I'm getting some comments coming in from folks that there's a lot of interference going on at the moment.
Yeah, I hear some hum in the background too.
Right, we've been having a little bit of audio trouble today with the meeting. So why don't you guys go ahead and type your questions in. And why don't I say this, let's type our questions and we're heading for a break, Bob. Maybe we can pick up a few quick questions on the other side of the break and then proceed with the rest of the day.
That's fine with me.
Okay.
That's fine with you.
If I may say one thing, thank you so much, all of you, for your continued support, for being in our corner, for being part of our community. If you have any questions that you need answered in the future, you think about something, please feel free to email us at aavso@aavso.org. We're going to direct them to the right person for you. So my gratitude to our community, and thank you actually to all the volunteers who comprise our board, Gordon and Bob and Greg and Chris, and well, we have 14 individuals who have been spending a lot of time thinking about the well-being, the continuity of this wonderful organization, and how we're going to build a strong and sustainable future for all of you and for all of us. So with that, Gordon, any final words before we have a coffee break?
No, I think that's great, and I appreciate that. And again, like Stella said, thank you all for being members, for supporting us. And I'll just finish with my phrase I always like: just have fun and enjoy being part of this community.
Yeah, thanks for geeking out with us.
Okay, we do have some questions popping up now. If you guys are ready, real quickly.
Okay.
You tell me, Bob, up to Bob Buckheim.
Mr. Buckheim.
Fine with me.
Okay. Heinsberg Egson says, has it been contemplated that the very name of the organization is limiting its potential to grow with respect to membership and grants?
There's been ongoing discussion of whether the name should change, and this is one of those, you put this out and you start a firestorm. So there is no current discussion about changing it. We may want to back off objectively and look at that. Everybody has their own opinion. Even I've had people in England tell me don't change it because other countries have their organizations, and then I have other people who say, you got to take American out of it. Let's just leave it this way for today. It is something that comes up right now. There are no plans to do it, and unless we saw some significant benefit, I don't think we would do it. But we'll think about it.
Jay Miller asked, to continue with kind of the educational thing, publishing a brochure for high school science teachers on what AAVSO does, etc. Any ideas?
What I'd like, unless Stella's has something active on that, I would say we want to put that on the list. And I mean that in all seriousness. I think that's the kind of thing that if we could do it, and maybe we could find some, volunteers to help put it together who come from the education community. But I think something like that, it would be a good idea.
Just to supplement, that's an excellent idea. We already have a web page with projects for students. You just Google AAVSO projects for students if you want. The recommendations if you have telescope time in your hands. But thank you for bringing it up. So we're going to work on that. It's a great idea to find a way of popularizing our projects for students a little bit more. And just remember, the Journal of the AAVSO is a journal where students can actually submit their own manuscripts and get published. And someone actually made a comment quite recently that, yeah, it is a big asset for a student's resume at the very early stages of their career to showcase that they have done some science and they have done some research. They have spent some time working on a project from the beginning to the end. They have a manuscript to show for it in a refereed journal. So absolutely.
Okay, we have a question from Michael Miller. Have there been any recent improvements in the bandwidth and efficiency of VPhoto?
I don't know the answer to that. I use VPhoto too, and I know what you're talking about because it depends what time of day or night you get on it. But if somebody submitted a time series with 1,000 images, you wait a while. Let me say that. Well, let me take an action to try to get an answer to that. I know there have been discussions. I don't about increasing the AWS capacity. Maybe we'll post an answer to that later.
Okay, Greg Jones brings up a question. Any thoughts on the happenings of things like ZTF, etc., clearinghouse for the alert system or streams, and any guidance on what might be important there?
I'm going to turn that one to Stella, maybe out of the section stuff and Elizabeth, Sarah's work.
I'd like a clarification, actually. Could you please repeat the question?
Okay, he was asking about the time domain streams that are coming in from places like ZTF.
Right.
And anything that that AAVSO might be able to promote, and is there any advice in that area? I think this was pretty much what the question was.
Yeah, most of the alerts that we have and the campaigns that we run are targets that are being requested by astronomer teams, not only professional astronomers, but members of our non-professional community. Targets that are usually aiming at a specific project. So someone has a graduate student or someone is running a project, they want a time series or they want long-term observations of a specific object. So they contact us and we connect them with the appropriate community to actually take observations. Right now, we don't have plans to actually find a way of streamlining all those alerts that come out of surveys. Think about it. ZTF may be coming up with several hundreds of alerts a day right now. LSST's advertising is going to be coming with about 1 million alerts a day. And this is a lot of stars. This is a lot of targets. Out of those alerts, we don't really know which ones are of interest to any individual in our community, anyone in our community for that matter. Not all of them are going to be objects that are interesting, and not all of them are going to be real. False alerts are a reality. So the bottom line is that for now, until we find a way of identifying targets through those surveys that are of interest to our community in a much more concentrated way, for now we're going to be driven by our community itself, the professional astronomers, the non-professional astronomers, individuals who are interested in specific stars for our alerts and campaigns. From there on, if you want to follow your own alerts, or you follow a specific target yourself for a project, for a student project, for your club's benefit, or anything like that, you can observe any of the alerts that are being published by any of the surveys that are out there. And we will be very happy to put the Lightcurve on our database. Just let us know. I hope this answers your question. Beg your pardon?
Oh, this is Greg Silverkopf. Can I add something?
Go ahead, Greg.
Who is?
It's Greg. Greg, go ahead, Greg.
Time here.
So just really quick, things like the future and alerts, etc., are all part of the strategic plan. We will think about these things, of course. We are very well aware that this is an issue.
Okay, we have
Wayne, we're getting on in time. We probably ought to hold the questions till the end of the session.
Okay, that's fine.
Some more, we can answer those then.
Okay, that sounds great. We'll be here.
At this time, we're going to take we're a few minutes late, but let's take a 5-minute break and be back here at say 15 after the hour.
Thank you all.
Thank you, Jerry. Thank you, everybody.
Okay. While you're on your break, I would recommend you look at the handout tab. There are 5 handouts out there, some of which are the actual presentations, the PDF of the presentations. We have a special flyer from DC3 Dreams that has some special pricing. There's some links to some of the previous recordings, and Software Bisque has some a PDF on their new products. And I'd recommend you take a look at those while you're on your break. See you.
And of course, the production team and Eric Hintz don't get a break yet because we need to get Eric trained.
Okay, we're coming back now from our break. We're going to hear from Steve Bisque. He's one of the owners of Software Bisque. I think you all are familiar with Software Bisque. He's going to tell us about some of his products that are just coming out. Take it away, Steve.
Okay, hello. First of all, I'd like to thank the organizers of SAS for shifting gears and making the SAS conference available online. Our world is currently a bit upside down, and it's comforting to maintain the relationships and make contact with the staff and our customers and friends out there. We have fond memories of this conference going all the way back to the 90s when we used to schlep our imaging systems out to Lake Arrowhead and stay up all night having fun and imaging with a lot of these same people that are still around. So today I'm going to give an overview of some of the newer products in our lineup. Of course, our line of German equatorial mounts, the MIGHTY, the MX, and the ME are our most popular robotic telescope mounts. And we're happy that during these difficult times, it seems that astronomers have got a lot more time for enjoying their passion, and that so they've been out doing a lot more imaging and that sort of thing. And it seems the industry is doing well, and certainly at Software Bisque, our sales are up significantly from last year. So, you know, that's a good thing. During the last 5 years, we've increased our product offerings so that we can provide imaging solutions to a much broader spectrum of people. And so I'm going to tell you about 6 new products that we've introduced since the last time we were here. Okay, so the first of these that I'd like to talk about is the Sky Imaging Edition. Now, over the years, we've had the Sky plus various add-ons, the camera add-on, the T-point add-on, dome add-on, that sort of thing. And the number of permutations that were available to the customer became unwieldy. And so we decided to start consolidating these products into simpler offerings, because when you throw in the additional choices of operating system, because we run under WinMac, Mac, and several types of Linux, the permutations are just way too great. So we recently introduced the Sky Imaging Edition, which combines a lot of the various components into a single thing. Let me change this. Okay, there we go. Oops, having a little difficulties here. Getting to the correct slide.
Go to the next one.
Yeah, there we go. There we go. So the Sky Imaging Edition, it combines T-Point, the camera add-on, and the Sky Professional Edition. And so with just a single install, you can now control, you know, an entire observatory of devices. And in addition to having the telescope pointing and camera control, as well as other devices like focusers, filter wheels, and that sort of thing. I wanted to remind you that there's a detailed PDF on the SAS site that has information about all of our products. So make sure you go take a look there if you've got additional questions about these things. Okay, so the Sky Astronomy software is actually a component of all of the 6 products that we introduced in the last year, except for one, a tripod. But it's very integral to our new product called the Sky Fusion, which is a built-in computer that has got the Sky pre-installed, and it's also got a bunch of ports for both plugging in all of your devices that you might be using in a portable or even a permanent setup, as well as a bunch of power ports to power those devices. The Sky Imaging Edition, there's a special version on there which can turn off and on the various devices that are plugged into those power ports. And then you can sit at a distance over Wi-Fi and do your imaging. And using the Linux operating system, the Fusion it's immune from a lot of the problems that you get with Windows updates. One of our biggest technical support issues is when there's a big Windows update, a lot of devices stop working and things have to be reinstalled. So that's one of the reasons why we chose the Linux operating system for the Fusion. It can sit up on top of your telescope and you plug everything into it. And so it really straightens up some of the spaghetti cable mess that you often get with your imaging system. We've been selling fork mounts now for 3 or 4 years, equatorial fork mounts, and they are all gear-driven systems up until recently. We decided to put our direct drive technologies onto the Taurus fork mount, along with on-axis absolute encoders that are 26 bits. The nice thing about the direct drive is it slews much faster than the gear-driven systems, and also there's just no wear and tear on the system, because the gears will not wear out after years of use. The Taurus equatorial direct drive comes with the TCS-PK, which is the same software that we're using on our ALTAS telescopes to control and take into account the T-point model, as well as a rotator, which is optional on the Taurus. We've now got a complete line of ALTAS direct drive mounts as well. We've been heading in this direction for many years, but it's taken a long time to get here. We've introduced the Apollo series of direct drive ALTAS mounts. With ALTAS mounts, there's the big advantages of ALTAS mounts. They take up a lot less room in an observatory, and they're also extremely stable with large loads. So something like a 0.5 or a 0.6 meter telescope is much easier to slew around because you don't have cantilevered mass, and it's not moving the telescope in all different directions. It just moves it in a couple different directions. We've sourced some really good high torque density motors. Again, we use 26-bit encoders on here, and it's all controlled by the TCS-PK software, which is used on a lot of the world's largest ALTAS systems for keeping control of the 3 axes that are required to follow stars. Now, one of the drawbacks of having an altitude azimuth system is the fact that you have to have a rotator. And the rotator should be able to keep up with the azimuth axis on the telescope. Otherwise, you can slew around and you have to sit and wait for the rotator to catch up. So we've introduced a rotator that's also direct drive, very similar to the axes that are on the other 2 axes of the mount, with 26-bit encoders and high torque direct drive motors. So we actually sell this with the Apollo mounts. It's optional for the Taurus mounts, but it comes with the ALTAS mounts, and it's just the 3rd axis that plugs right into the controller that controls all 3 axes. And finally, we introduced the helium tripod. We showed this at AIC, and we've been shipping it now for several months. We've got quite a few of them out there. But it's an ultralight 14-pound tripod that's very adjustable, and it can support up to 200 pounds of payload. And it can accommodate sloped surfaces, and it's real quick to set up and tear down. So it's a great tripod for portable imaging. So that's kind of a quick overview of the 6 products that we introduced. I'd like to go ahead and answer questions now, and if anybody's got questions that they'd like to put forth.
Steve, I have a question. With your Apollo mounts, how close to the zenith can you work?
You can get it's dependent on a couple different things, but you can track within about a degree. You know, that does require that also requires a fast rotator. But you know, ours is plenty fast enough to get to about a degree.
Any other questions?
Yeah, we have a couple of questions from the audience. Ken Hudson asked, when will the Fusion be available?
We've had very soon. We've had a few supply problems due to COVID, and that kind of slowed us down a little bit. But we've got the first production run assembled. We're iterating a couple last-minute software images that we copy onto them, but we expect to be, you know, shipping the first units in July.
Okay, Jay Miller asked, he didn't see SBIG in the camera list for Fusion.
Okay, the legacy SBIG stuff is in there, and we're working with diffraction right now to get the 64-bit drivers that we need to control their newer cameras.
Okay. Daryl Moon asked, is the Sky Fusion, will there be any built-in support for asteroid research, like updating orders from the Minor Planet Center, mount tracking of asteroids, astrometry reduction, and reporting to the MPC, the Minor Planet Center, via email, etc.?
Some of those things, yes, some no. I mean, we basically everything that the Sky does on Windows or on your computer, Fusion can do, and we don't expect to be updating it quite as often with you know, operating system stuff. But if it's built into the Sky for Windows for your desktop, then yes. But some of those features, I would say, you know, I don't recognize them, and you know, we just don't have them right now.
Okay, so Ray Tomlin has asked, does the Mighty route cables through the mount?
Yes, absolutely.
And on with Fusion, Charles Simon asked, how many USB ports does the Fusion have?
It's got 4 USB 3 ports, and we are going to be offering, or you can use other off-the-shelf ones, but we've sourced some good USB hubs, so you can add a hub, which will give you some additional ports. You know, they don't necessarily work well with high-speed devices like big camera, you know, cameras with big sensors. But if you use one of the built-in ports for your camera with a big sensor, and then if you got more than 4 devices to plug in, you could put a hub on there. There's also an RS-232 port available, so that kind of gives you one more. Because there's still a lot of serial devices on the market.
Okay, and Tom Smith brings up the question, what is the through clearance on the Apollo from the altitude bearing to the fork base?
And it's variable. I mean, we can adjust it. I mean, it depends, of course, on the optic and the balance of the optic. But the standard one with a half-meter telescope, you can usually swing through, you know, with something going a little bit behind the focal plane. But if you needed additional room, we can make the forks longer.
Excellent. Well, this is a note to some of us. We seem to be having a few audio issues out there with opening people's microphones. I think it's definitely a good idea to stick with the typed in questions. So Jerry, let's see, we have one just popped up from Steve Timmons. Is Software Bisque offering any SES show discounts?
I did not think about that. But if you want to contact me directly, steve@bisque.com or steven@bisque.com, and tell me what you're interested in, we can see if we can work something out.
Excellent. Excellent. Okay, Jerry, I'm turning it back over to you.
Okay. Thank you very much, Steve. And folks, Software Bisque has been, like he said, has been a long time sponsor of SAS. And we appreciate his sponsorship and the camaraderie over the years. Thank you very much, Steve.
Been a fun
Also,
ride.
I might add, did everybody catch they had 6 new products being released this year? Those of you who have done product development, you got to shake your head and say that's phenomenal.
Or stupid.
No, not stupid. Thank you, Steve.
Jerry and Steve, were we doing a raffle? I don't remember.
I'll blame Peter for not telling me about that. But we can do something. Certainly, we can copy the Sky Professional or something.
Well, I don't want to put you on the spot. I think I remember Peter talking about Sky Imaging Edition. Am I remembering that right, Jerry?
I believe so, yes.
Okay. Yeah. So then yes, we are.
Okay.
Okay. In that case, I've got the bowl here, and it's got tickets in it. And Jerry, you probably received the updated cross-reference between names and numbers this morning?
I did, yes.
Okay, so for the assembled multitude, same as the raffle we did with DC3 Dreams, I went through the roster of everybody who paid for the symposium, lined them up with a ticket number, which Jerry has that list. I have the tickets here. I will shuffle through and pull a ticket. The rules are you must be present in order to win. So if the first ticket number is somebody who's not actually online today, we'll pull another one. SAS board members are not eligible. AAVSO board members and staff are not eligible. So here's tickets mixed up. And I've got number 791222.
222. That's Gary Beckstrom.
Gary. Let's see, do we dare unmute Gary? Let's see what happens. He's on the phone. Gary, are you still there?
I'm still here.
Okay, congratulations.
Hey, thank you so much, Steve. That's perfect.
Yeah.
Steve, we'll send
All right.
the contact information to you.
Okay, great.
Thank you.
Congratulations, Gary. And I will add my thanks and respect to Software Bisque. Steve, I love my Paramount and the SkyX Pro.
Great.
Jerry?
Okay. Next, we're going to hear from Eric Hines. Excuse me. Let me get him turned on. Eric's going to talk to us about confirming short period pulsating variable stars with an array of small telescopes.
Yes, it's going to sound like advertising for everything else that happened today. As strange as that sounds. Okay, have we got the controls transferred over? Yeah, there we go. Okay, well, greetings from Utah. And a rather empty building. I thought of doing this up in the dome with the telescope, but thought better of it. But what we're going to look at today is some of the stuff we're doing on campus using our telescopes to try to follow up on a number of projects that are out there that have been discussed today a little bit about the idea of programs that are generating a lot of data. I do have to acknowledge some of my students. Jared, Jacob, and Elizabeth do a lot of the observing with the robots upstairs. One that some people might find interesting from what I've heard discussed today, I have a student, Marcelo, who's working on some variable stars, the same projects, but he's actually developing a high school competition based on variable star data that we're getting with our robots, and we've got a couple schools lined up to test that, so that should be an interesting one. And then I have another student that does a lot of data reduction. And when the targets get too faint for our campus observatory, we can use our bigger telescope out at West Mountain that Mike Joner runs for us. And if you're interested at all, now a little plug for the AAVSO here, the short period pulsating variable section, the SPP section, the webinar will be August 8th. So if you're interested in that, or you can always get hold of me if you're interested in those kind of targets. So a little bit of background here. There's a lot of programs that are generating a whole lot of data, looking for not necessarily the variable stars I'm fond of, which are mostly Delta Scutis or Beta Cephei's. In the case of the Atlas project, they're looking for asteroids that might hit us. You have the Assassin project with the supernovas, obviously the transiting planets earlier with Kelt and now moving on to the TESS satellite, and all looking forward to LSST coming online and generating a whole lot more. There is the byproduct that comes up here that there's a lot of other variables in the field than say the asteroids, which is the program mostly we'll look at today with Atlas. But all these programs have different cadences, and most of them are a cadence rate that doesn't match well for the very short period variables. So basically what we've been doing with our campus facilities here is to see how reliable the classifications that are coming out of these programs actually are. What happens? Are they giving us accurate periods? Are they giving us accurate designations for the targets? And so we were playing with that a little bit. That actually all started from chairing a session at the American Astronomical Society. Somebody doing a presentation on Atlas and getting a whole target list from them. So basically our targets here of interest, kind of a little hard to see, I think, here, but mostly right down here with the Delta Scutis and up here with the Beta Cephei's. So the short period ones where we're dealing with 30 minutes up to 3 to 4 hours, we found these to be great targets for our undergraduate program. Just to let you know, we have, talking about people interested in, students interested in astronomy, we have 60 astronomy majors in our department. So there's definitely a interest on the youth side in astronomy in general, and then we use the variable stars as a great target for them to chase. And the nice thing is they get to see a a light curve in a single night. And I should mention, we also do transits while we're at it. So equipment-wise, we are equal opportunity here. Since we've talked about the software BISC, we've got 4 of their systems out on the deck, 2 MEs and 2 MYTs. And you can kind of see in the long picture here, the dome in the background, which is the another telescope. You can see here we have a plane wave system up in there, and I'll go through the specifics of the systems. Our one and only problem really on campus right now is this big tall building, kind of in the northwest corner, but we managed to work around it most of the time. There's only a few targets that occasionally will track into it. But you can see our observation deck, that was redone about 3 years ago, designed for data and power at each of 8 pedestals, 5 of which are going to be set up as robotic telescopes. 4 systems are currently operational. And if we look here at the systems, we've got a 24-inch plane wave on an L600 mount up in the dome, a 12-inch on a ME, a 10-inch on an ME, an 8 on an MYT, and a 5, which should be going to a 6-inch on another MYT. We run SBIGs, we run Finger Lakes. Like I said, we're equal opportunity as we go through here. And we run through a range of different filters for a little bit of different science, and we run a lot of different softwares. So we have the MaxMDL for CCD control, SkyX, and then autopilot between the two. Most nights we like to program the entire night into the computer and let it just run. And so we can go home and sleep so that when we have to come teach, we've actually slept the night before. And even with the virus, we still have to teach. And planning for the fall has been an interesting problem, especially with a class that is designed around using these telescopes. It's kind of hard to teach them how to get the telescopes ready for the night when they can't touch them. So we're hoping in the fall that we will be able to have the students here and working live on the systems. I should note, we do run the PlaneWave software on the 24, and we have an automated, we've automated the dome to track with that telescope. So basically we can run all the systems completely autonomously all night, at least down here on campus. And I should note one thing about our observatory. For a lot of people, this might be considered high level. We're at 4,600 feet here on campus. Our West Mountain facility is close to 7,000 feet. So we're used to some higher elevations, even right on campus. Should mention, again, I just mentioned West Mountain. So we do have the pictures off to the right-hand side here are some shots of our West Mountain facility and the 36-inch telescope that's out there. And it's kind of a fun site. It's getting a little brighter skied. Salt Lake does us in a little bit to the north, but for the most part, we do okay. And then we are using telescopes up on Vancouver Island. The 1.2 meter, 1.8 meter at the Dominion Astrophysical Observatory. We're trying to get some of our fainter targets on the 1.8 meter coming up the next semester. And the 1.2 meter has been providing spectroscopy. I was scrambling this morning when I got for this meeting. I had forgotten to send my target list because I have the next 6 nights on the 1.2 meter. And I hadn't given them the target lists. And so I was scrambling this morning. But the targets are now in, and hopefully I can stop panicking. Okay. So here's kind of an example of what we've been following up on here. So this is what we've numbered. This is our own numbering system for the Atlas stars that we've selected. We basically did a selection criteria on the period found by the program and the colors, because they shot in 2 different filters, so we can kind of get an estimate of the color of the star. And so we can pick here, trying to get stuff in the instability strip of about the right period. This is Atlas 70, and period here of about 2 hours, almost exactly 2 hours. And we're looking about 13th magnitude. And Atlas came up with a couple different lists. One of them was pulsating variables, and one was multi-periodic variables. This one is listed in the monoperiodic set. You also notice it has a guide star number up there on top. And the example on the bottom of the page here is the data stream that's coming off of the Atlas program. Now, if you're looking here, this is over quite a few nights, from one side of this graph to the other in 2 kind of seasons, but you're not seeing a single night that seems to have a lot of data on it, except maybe here in this range. You're maybe getting a little bit more on a single night, but for the most part, you're only getting a few observations a night, and then they're going to run this data string through and try to classify the type of variable and then the period. Well, turns out a couple things happen interestingly with the Atlas 70. There's a thing, this is one of the longest nights, single string nights of data that's from Atlas itself. And the bottom is actually the phased curve of all their data. Looking at that, this is probably not monoperiodic. So a couple things pop out really quickly. And over here to the right is our single night of observing with the 24-inch. Kind of getting a little different perspective on the shape of this curve and what we might expect actually from this star. One thing I want to point out, this is the very first light curve generated by the 24-inch. This is the first night we were running it. So we were still guessing on exposure times and things like that. So this is actually kind of exciting. We're starting to go through a pretty substantial list. I think somewhere in here I do have the list of how many targets we have to sort through from all these different programs, and there's a lot of work. Even all our telescopes here are, once we get all the systems running, we'll have 9 robotic telescopes between the mountain and campus, and it's not enough telescopes. There's a lot of opportunity here for people to follow up on targets, check whether the published values are correct. I'll give you some idea what goes kind of wrong later. Just a few more of the targets here. Just showing some of the other light curves that we've managed for some of our other ones out of the Atlas program. You can see up here Atlas stars, and then we have some that are labeled as M-Atlas. These are actually the multi-periodic ones, which we can't see out of a single night, but they're there. And then these are actually some of the ones from fainter ones from the mountain. So these are more in the 16th magnitude range, and we're done with the 36-inch. This, I should note on the left-hand side, is actually listed in this monoperiodic sample, but clearly there is a different in the amplitude cycle to cycle. This is probably a multi-periodic star, and so a longer data string could sort through that. This is also listed as a monoperiodic pulsator, but it definitely has 2 very different heights at different nights. So that's one of the things we're noticing, that their system of classifying pulsator versus multi-pulsators isn't picking up the multi-periodic very cleanly. To give you an idea of our overall program here, 1,157 pulsating monoperiodic stars in the Atlas database that matched our search criteria, 375 multi-pulse. We also have on the order of 5,000 variables that came out of the KELT database that we are also following up to see how their classification system was working. Now we should note that some of that, so that looks like a lot of stars, and those aren't all new variable stars. Some are actually previously known, but a fair number of them are not. Some are in other surveys, but a lot of these are the first time they've been discovered as variables, which does make them really nice student targets. Handing them something that nobody's ever worked with before is always kind of nice. We've gotten 14 pulsating variables from our campus, 8 of the multi-pulse, and that's about 200 separate light curves so far. And really the deck has been only fully operational in the dome since about February. And so some of the telescopes have been running about a year, but for all the systems, it hasn't been that long. So we've been generating a lot of light curves from the campus. 6 of the targets have been observed with the 36-inch on the mountain. And again, another sample maybe with the 1.8 meter in the future. So what did we find out of what we've seen so far?
5 minutes.
Thank you. Basically, some stars in the pulsating catalog are actually multi-periodic. Actually, a lot of them are. And that could be different, where people wanting to find targets for something like an astroseismology project, they might discount anything in the pulsational list and only go to the multi-periodic list, but they would be throwing out a lot of potential targets. The one thing their classification system has trouble with is, as the amplitude grows smaller, their period estimates tend to become to miss more often. So an example, one of the Atlas targets here is that from the Atlas program, they had a period of 0.21 days, so about 5 hours. We have a light curve that puts the period somewhere in the order of 3 hours. So, and this is not a multiple. So that's an interesting problem. The one place there's a lot of errors here is in the multipulse. A lot of times the period published in their catalog is a multiple of the real period. And this could lead to confusion where somebody might think something is an RLRE, which is actually a delta Scuti with, say, a third of the period. So it makes sorting out their data and actually could make some conclusions wrong if somebody was trusting the data blindly. So in a sense, this is going to be something that comes out of something like LSST, large samples of pulsating variables, and we don't know whether maybe all the numbers aren't right. And so any of these big surveys, we have to go back in and check what their consistency is. I've seen the same, Atlas has these issues. I've seen the same in the Kelt database. Stars that don't make any sense in their HR diagram position until you realize the periods were off, and then they shift, then they make sense. So in a lot of cases, the instability strips that are represented from the data are wrong. And so you've got to follow back up on these. Period luminosity relations come out of these type stars, so we got to make sure we're picking the right stars. And so as we head into LSST, which is going to have even a longer cadence period, how is that going to impact our data as we go through? So basically anybody with a small telescope with a CCD and reasonably good tracking can help follow up on these. There's plenty of targets out there. They lead to really good papers. Some of my undergraduates have published in the research notes of the AAVS. They're also working on papers to go in the JAAVSO for some of our more extensive data sets. And so those papers hopefully will get submitted soon as I push them a little bit. And just need to acknowledge a couple sources here. We have the observation deck was built on a NASA Rocky Mountain Space Grant Consortium grant. The 24-inch was funded extensively by the Mount Cuba Foundation and then filled in by our own college here. And so we got to acknowledge those funding sources. So I will leave you at that point for any questions.
Okay, thank you, Eric. We have time for some questions.
Yeah, we have a few questions queued up. Sebastian Otero says, Eric, I see you have made plots with Atlas observations. Where can Atlas Epoch Photometry be downloaded from?
Actually, if you look up the Atlas program, they just go through their website. It's in the Space Telescope under MAST is where you can do a search in there. But if you go to their, so if you just do a search on Atlas, you'll get the original paper, and then you can get the how to search their database. They have complete instructions for searching it.
And Richard Post asks, how does your results get feedback into the Atlas catalog?
Actually, right now we don't. We're basically getting the first stages of getting things published, and hopefully can note the differences as we go through. So if we have a sample of 10 or 12 stars, we can show which ones match, which ones don't, but it'll be basically from the publishing.
Okay, Roy Tomlin says the list of 5,000, let's see, is your list of 5,000 on the SPP section site?
Not yet. There's a lot of stuff I'd like to get on the SPP site. Right now, my department made the mistake of making me associate chair, so they made my time disappear a little bit. So I'm not getting quite as much on there as I'd like. There's been some conversations on the SPP discussion board about making a list of on different magnitude ranges that people might be able to chase for different size telescopes. And I've been trying to work up that list. So hopefully that will be there in the not too distant future. I'm hoping.
So Jerry, the board's clear. I'm going to turn it back over to you.
Okay. Thank you, Wayne. Eric, thank you very much for this. I don't know whether you realize I'm in southern Utah in St. George area. So.
Oh, okay.
And I've been up to West Mountain.
Okay.
There, Richard.
Yep.
Thank you very much, Eric.
Yep.
Next, we're going to hear from, let me get some cameras turned on here. We're going to hear next from Sujay Nair and Jonathan Varghese. I'm probably pronouncing that wrong, Jonathan. I apologize for that.
It's all right. Varghese. Yeah.
Varghese, got it. They're going to talk about transit analysis of HAT P23b, Qatar 1b, WASP 2b, WASP 33b, with an optimized exoplanet transit interpretation code. Thank you.
All right, so hi, I'm Sujay Nair.
I'm Jonathan.
And so as said before, we looked at these 4 exoplanets with optimized exoplanet transit interpretation code. So exoplanets are planets outside of our solar system, and the most common way of detecting them is by this method known as the transit method. This involves plotting the relative brightness of the star against a comparison star over an exoplanet's transit, and that makes a light curve. And in this, we look for a dip in brightness that could indicate an exoplanet. The mid-transit time is the time in which that exoplanet is in the middle of its transit, and the error on this mid-transit time increases over time due to the uncertainty in the period of the exoplanet. And so because of that error, we need to continuously observe exoplanets to update transit timings. And so that's why that's extremely important. So we use the exoplanet transit interpretation code, which is also known as exotic, which takes in .fits files or pre-reduced text files and creates a light curve. And we also made some edits to the code to speed up the photometry.
So we received our image data from Pat Boyce of the SRO Observatory. We chose to analyze these 4 exoplanets because the data was previously unanalyzed and the exoplanets had high expected transit depths, short transit durations, and short periods. Within these planets, we worked with both uncalibrated and calibrated data, and also the Qatar 1b and WASP 2b data had a meridian flip, which is where the telescope has to rotate 180 degrees due to the star crossing the meridian. So a very time-consuming section of exotic was the photometry. So the main drawback was that there was repetitive calculations being done when calculating the optimal comparison star. So we edited the code base to store values into a dictionary, so it didn't have to recalculate the same adjustments every time. The current build of exotic has this photometry speed up implemented. And we also experimented with trying to run potentially GPU compatible sections of exotic on the Google Cloud platform, but we did not see any significant speedups. So the first planet we researched was HAT P23b. So during our analysis, we made light curves of uncalibrated data and calibrated data. The image on the left shows the light curve without any additional calibration frames. And the image on the right shows the light curve with the calibration frames. Generally, we can see the exotic was able to fit a curve with less scatter and lower uncertainties with the calibrations. We compared the calculated transit midpoint to an existing confirmed transit midpoint and saw a phase difference of about 24 minutes, indicating that the midpoint was slightly off. So throughout our analysis of WASP 33b, we made light curves of a partial series of raw images and the full set of raw images. So our partial transit light curve is on the left and the full transit is on the right. So we received an extremely large and unlikely phase difference. So it's very likely that the large difference was either due to noise in the data or a misfit by exotic.
So over the course of our analysis of Qatar 1b, we made 1 partial transit light curve and 1 full transit light curve. And this is the data that contained a meridian flip. The image on the left shows a 50 image section of the transit around that transit midpoint, and the complete light curve can be seen in the image on the right. In order to make that complete light curve, we had to account for that meridian flip. And so what we did is we made text files of the relative fluxes between the target and comparison star for both sides of the meridian flip separately. And so to make the final light curve, we just combined these flux files And though since we use these separate flux files, we couldn't add calibration frames. And in the end, we saw a phase difference of close to 40 minutes. So like HAT P23b, this was off. So like Qatar 1b, during our analysis of WAS2b, we had to work with data with a meridian flip. And so here we just plotted the FITS files of both sides separately. And the image on the left shows the light curve up till the flip, whereas the image on the right shows the light curve after the flip. We again saw a really unlikely phase difference, and this was probably because of noise in the data or a misfit by exotic. So in conclusion, we were able to successfully produce a calibrated light curve for HAT P23b, and we saw a clear decrease in uncertainty and the residuals using calibration frames. We were able to freshen the transit midpoint of HAT P23b by around 20 minutes, and we have high confidence of an accurate measurement due to the clean light curve. We were unsure about the transit midpoint for WASP-33 and WASP-2b as the phase differences were really large, and this was probably because of a misfit by exotic or just noise in the data. For Qatar 1b, we were able to update the transit midpoint by around 40 minutes, and we also have high confidence in this measurement as all its light curves are really clear. And lastly, we were able to speed up the exotic code by a factor that scales linearly by the number of .fits files that were used. And so finally, we just want to thank Kalei Tak and Dr. Rob Zellum for their immense help throughout this project. Thanks.
Thanks, guys. We have time for a question or two.
Yes, Christina Legrand says, please read the question. She has no microphone. Yes, I'm reading your question. Is the software for exotic open source? I think that was answered earlier in, and you can go back and watch a presentation about that from the first day.
Yeah.
And congratulations on getting your changes into that code.
Thanks.
Let's see. Wayne Thomas says, what is the uncertainty in these measurements?
I don't know about the exact percentages, but we know that for exoplanets like Qatar 1b and HAT P23b, we got pretty low uncertainties, like very small decimals, whereas like for those really noisy light curves where we got that odd mid-transit phase difference, we had extremely high uncertainties. So that probably contributed to the odd mid-transit times and such.
Okay, let's see, coming down the list here, Ken Hudson says, wait, that's another question. What type of calibration did you use? This is from Gary Walker. What type of calibration did you use? Bias, darks, flats, things like that?
Yeah, it was bias, darks, and flats, yeah.
Okay,
I can't remember the exact bins and stuff, but yeah, it was those three.
Okay, so you used a set of calibration data, it seems like up to the meridian flip, and then you said you did not use calibration data after that?
Or on the Qatar 1b, where we had to combine the two flux files, we couldn't use calibrations at all because after like reducing it, I don't think at that time it was an option to include calibration frames. But with like HAT P23, we didn't have a meridian flip, so we could just run the whole transit through where we could, include those calibration frames. And that was part of exotic, where you could include, darks, flats, and biases.
Okay, interesting, thank you. Let's see, Tom Polakis is asking, by calibrated, do you simply mean the usual darks and bias flats?
Yeah. We just like, some of them we just like put in the raw images, and then calibrated, we just like put in whatever the, so Pat Boys had like some calibration frames for every like exoplanet, so we just use those.
Okay, and then you said, never mind, I should read the list a little bit more closely. Let's see, we're going to queue up the question, I think. Ken Hudson was asking, he says he's left, so we're going to ignore that question. Let's see, I think I have everybody off of the board. Yes. So Jerry, I'll turn this back over to you.
Okay. Thank you very much, Sujay and Jonathan. That's some mighty nice work. Next, we're going to hear from a group: Elias Kubal, Lane E, Greta Olson, Ivan Altunen, and Kelly Tak. And let's see, we'll get everybody turned on here. All right. Go ahead.
Okay. So this is assessing habitability of exoplanet targets. Hold on. There we go. Okay. So we first needed to choose appropriate exoplanet systems to study, and those are systems of planets outside of the solar system. There are currently over 4,000 confirmed systems, so we created our own criteria to reduce this list. Some conditions limited the orbital period of the exoplanet, and others minimized the temperature of the host star. Our final targets were Cutter 8b and KPS-1b, which satisfied all of our conditions. We requested images of our targets from the Las Cumbres Observatory telescope network. We wanted the telescopes to take images as the planet crossed the visible surface of the star or transited the star. Requesting our images required some mathematical input to determine when the next transit would occur. Our images were returned to us through the Our Solar Siblings pipeline. For our research, we wanted to measure the host star's light intensity as a function of time as the planet transited the light, as the planet crossed the star's diameter. The planet blocks out a bit of the star's light, which decreases its visual brightness by a small amount. We measured the variation of the host star's brightness as the planet transited relative to a nearby comparison or comp star. This serves to eliminate some negative effects on our images. We selected 5 appropriate comp stars using Asteroid J, which are marked in green on the slide.
We made these plots using EXOTIC, which stands for the Exoplanet Transit Interpretation Code. Or next slide. Next one. Yeah. Or no, previous. Sorry. Okay. Yeah, so these light curves were plotted with EXOTIC. This software filtered through our images and used background information about our systems from the NASA Exoplanet Archive to generate a plot of the host brightness as a function of time. Our graph for KPS-1b was clear and accurate. However, our final graph for Cutter 8b was still noisy despite multiple photometric methods and showed an incorrect dip in the brightness of the host or transit depth. We also wanted to find a new way to represent the habitability of an exoplanet on a scale between 0 and 1. This new scale was inspired by pre-existing metrics such as the Earth Similarity Index, or ESI. We wanted this new scale to encompass a greater range of the planet's parameters, such as distortion of its orbit around the host, which then introduces climate variation. A value of 0 indicates an uninhabitable planet, while a score of 1 would represent perfect Earth-like habitability. We defined 2 separate calculations of our index, one for planets with a mass that is larger than the Earth, and the other for planets that have a smaller mass than the Earth. The equation shown above The equation shown above computes the habitability for a planet with a mass exceeding Earth. The symbols in the equation represent the temperature of the planet, the rate of energy reaching the planet's surface, the minimum mass of a gas particle that remains in the planet's atmosphere, the mass of the exoplanet, and the distortion of its orbit around the host. Our final metric is a weighted evaluation of all these factors.
All right, it was mute. We wanted to check our metrics accuracy and compare it to other results carrying out the scientific method. We graphed the Earth Similarity Index, which is the pre-existing metric, as a function of our habitability index, a special plot you see here, for 40 randomly selected planets from the NASA Exoplanet Archive, as well as papers, to measure the correlation between these two metrics. A strong link between the measurements means that the points will roughly fit on the self-made trend line, which has an equation of y equals x. So the points fit this line to an accuracy of 61%, which is called the R-squared value, the coefficient of determination. So the green regions on the plot, as predicted, correspond to planets with higher habitabilities, while the planets in the amber and red regions have lower habitability scores. Both of our selected targets are large hot planets, which are called hot Jupiters, due to their properties being similar to the planet Jupiter. Cutter 8b scores around 0.00679 on our index, while KPS-1b is even more extreme and scores just 0.00232. Both planets have temperatures in excess of 1450 Kelvin, at which human tissues and cells would completely burn. Our habitability evaluation and all of our scientific evidence strongly suggests that these planets are not habitable.
Thank you. Do we have any questions?
There are no questions on my board at the moment.
All right. Thank you all very much. We appreciate this information. Next, we're going to hear from Sujay Nair again and Krithi Cody. Oh, and Kaylee Chalk.
All right, so yeah, I'm Sujay, and
I'm Krithi.
And so, yeah, we looked at candidate exoplanet TOI 717.01, and then the confirmed HAP P3b.
Exoplanets are planets that orbit around stars outside of our solar system, and many exoplanets have been detected using the transit method. So the transit method involves creating a plot of the apparent brightness of a star against time and looking for decreases in its brightness. As when a planet comes in front of its star, it blocks some of the light that we receive, similar to what happens during a solar eclipse, except an exoplanet does not block all of its star's light. By looking for repeating dips in a star's brightness that correspond to the planet coming in front of the star, exoplanets can be located. Every revolution of the planet will have a dip in brightness corresponding to the planet being in front of the star. A plot of a star's brightness that shows such a dip is known as a light curve, and an ideal light curve is seen on the slide. So light curves are important because they give valuable information about exoplanets. For example, by looking at how much the star's brightness decreases, the planet's size can be found. This is because a larger planet will block more of its star's light than a smaller planet. By finding the time in between dips, the time the planet takes to complete a revolution around its star can also be found. Finally, the time at which the dip in brightness is the greatest is known as a mid-transit time, which shows when the transit occurs.
So why do we want to continuously look at exoplanets? Well, it's really important to look at these exoplanets because that mid-transit information changes over time. Mid-transit times change over time because of the error on their measurements. So take a person's clothes, for example. If they never wash their clothes, those clothes would get dirtier and dirtier as time progressed. So similarly, if mid-transit times are not updated, then their errors will become really large, and that will severely hinder observations from large telescopes, for example. And this happens because, well, transits are supposed to happen around their transit midpoint. And if that time is incorrect, then many telescopes will not be able to observe the transit properly. Like, for example, each minute of wasted time on the James Webb Space Telescope should cost close to $4,000. So just as we wash our clothes to clean them, we have to continuously update exoplanet transit, mid-transit information. We used, again, a Python script called the Exoplanet Transit Interpretation Code, also known as EXOTIC, to create light curves from our data, which we received from the Las Cumbres Observatory, also known as LCO. On the left, we see a light curve made of the exoplanet HAP P3b, and after looking at the difference between the previously accepted mid-transit time on the NASA Exoplanet Archive and what we calculated, we saw a difference of around 20 minutes. And we're confident in that measure of 20 minutes for two reasons. One, our light curves made of HAP P3b all gave that difference of around 20 minutes. And we can see that the plot shown on the left of the slide is really similar to that ideal plot we want to see. On the right, we see a light curve made of the possible exoplanet, TOI 717.01. And we also made many light curves. However, the light curves were really messy, and they didn't give that ideal look as shown from HAP P3b. And because of this, we did not get a new value with high confidence to call the transit updated, though from our observations, that task may have been easier with a higher power telescope. So in conclusion, we can see that HAP P3b's mid-transit information has been updated, though it is pretty unclear for TOI 717.01. Though from this research, we can see that it's really important to continually update exoplanet transit information.
So we would like We would like to thank our TA, Elliot, and Mrs. Talk for their invaluable help with our project, Michael Fitzgerald for his ExoCrest script, Las Cumbres Observatory for the data, and Dr. Zellum and the Exoplanet Watch team for their help with our questions about exotic. For more information, you can visit our Google Drive folder from the following QR code.
Thank you very much. Do we have any questions, Wayne?
Jerry, I'm not seeing any questions at the moment. Turning it back over to you.
Okay. Thank you very much, guys. This is some good work. Next, we're going to hear from Quinn Perian and Paige Young, and a whole bunch of co-authors: Peyton Robertson, Michael Fitzgerald, Robert Zellum, Martin Fowler, and Kaylee Talk.
Hello, I'm Quinn Perian, and I'll be presenting on analyzing the transit timing variations of trace 1b with Paige Young. As was mentioned, we have other co-authors on the paper too, which were Peyton Robertson, Michael Fitzgerald, Robert Zellum, Martin Fowler, and Clay Talk. So as an outline, we'll start by giving a brief introduction to the transit method, then some more information on trace 1b. Then we'll talk about gathering and using observations. Then we'll talk about how we qualified light curves. And finally, we'll talk about looking at transit timing variations. So the transit method is the method we use to be able to find exoplanets. So as they pass between us and a star, we're able to look at the light curve, or the amount of light from that star over time. And from that, when we see a dip, we can infer that there was a planet passing between us and that star. And we can use that and several of those observations to infer the existence of a planet, some information about its size, and also get a better idea of its period. And we'll see more uses of this for the transit timing variation later on. So some background on trace 1b. It's of course an exoplanet, so it's a planet outside our solar system. It's a hot Jupiter, so it was a good candidate for observation because it's large, like Jupiter, and close to its host star. This gave it a shorter period. It was about 3 days specifically, and a bigger dip, which let us have lots of observations to analyze, which was critical for looking at the TTPs.
So we used small telescope observations from telescopes in the micro observatory network to make new transit observations. So you can see a picture of them below. New transit observations allow us to check for other planets because other planets would affect the timing of the transit. And if there are other planets, we would expect to see a pattern in the transit midpoints we observe versus the transit midpoints we would expect in the case where there are no other planets. So we used a program called Exotic, the exoplanet transit interpretation code, to display the light curves for Trans 1b. So we only used the light curves for which there was a clear dip, like the one in the top left. So these were the light curves that indicated that a planet was transiting in front of the star. After looking at the light curves, we compared the transit midpoints we got from the transits we observed to the transit midpoints we calculated from hosted data about Trans 1b. And other planets would affect the timing of the transit. So in that case, we would expect pattern variation in the observed minus calculated values. And because the pattern variation was not there, you can see the plot on the slide. our results did not indicate that another planet existed. And yeah, so here you can see another. Here you can see another plot. So this basically, since there are multiple peaks here, not like one clear, not like just one clear peak. This indicates that the pattern variation isn't there, and that there isn't another planet. So there's no periodicity. And lastly, we would like to acknowledge Frank Sinkovich. We use the Python modules astropy.io.fits and astropy.timeseries.lumpscargle. And we use the source extractor module for Python, which uses source extractor. And that concludes our presentation. Thank you for listening.
And you can scan this barcode to get a link to more documents that give more information on what we did.
Thank you very much.
So Jerry, we have a question. Is there a central repository for transit timing updates that is accessible by astronomers?
As far as what we did, for the data we used, we got it from Micro Observatory, and this data can be submitted to the AAVSO catalog, which is one catalog that serves as a reference for the new observations.
Okay.
Dennis Conti is in the audience. Maybe we could put him on the spot regarding that question of a database.
Let's see if we can find Dennis. There he is. Dennis, I'm going to open your microphone up. There you go. Dennis, are you with us? And it just closed on me. Okay, try again. Dennis, are you with us there?
Yeah, can you hear me okay?
Yeah, we got you now.
Okay, yeah, so to answer the question, a couple comments. First of all, NASA maintains an exoplanet archive that contains the latest observations and ephemerides of confirmed exoplanets. And I don't know if one of the students was referring to the AAVSO exoplanet database, of which we're looking to start storing updated observations of some of the exoplanets where there's some uncertainties, will help the professional community get a better refined, again, set of ephemerides for confirmed exoplanets. Don't know if that answered the question, but those are two databases that store up-to-date information, particularly the NASA database, and more recently, the AAVSO will start storing observations.
Dennis, before you go, I have a question. Are the past transit time, mid-transit times saved? So if someone wanted to go back into that database and look for variations over a period of years, could perhaps find something?
Yes, yeah. In both, well, the NASA database certainly has the mid-transit time, and the AAVSO database, we store the observations there as so one can actually recreate the light curve and find the mid-transit time of any of the observations. And there's provision in some of the metadata in the headers in the AAVSO report where the observer can in fact record the mid-transit time that they saw in their analysis.
Thank you. Guys, thank you very much.
We have one more question here. Heinz Eggenstein asked, what were the apertures of the, I guess it was the micro telescopes?
I believe they were 6 inches. Yeah, I believe so.
That sounds about right. I think that was also reported on during day one, and you can go back to the video and check that one there. So
Wayne,
he says thank you. Jerry, I'm
Wayne,
going to turn it back over to you.
Okay.
Jerry and Wayne, Rob Zellum shows his hand raised. He may want to make a comment or a question about some of this.
Hand just went down.
Okay, now it's
And
back
it came
up.
back up. So let's try him again. So Rob, trying to open your microphone as usual. It's not letting me. Maybe, there we go. Hi, Rob.
Hey guys, just want to say thank you to Calais and all of her students. They've done really awesome work using Exotic, our data reduction software. Just to answer the previous question, you can actually get it on GitHub. So just Google GitHub, GITHUB, and Exotic. Alternatively, you can also look at our website. It's just Google NASA Exoplanet Watch. So this is our citizen science project that's looking to update these mid-transit times that Quinn and Paige were talking about, and also Sujay and some previous conversations or presentations have been talking about. And if you want to get involved, that'd be great. We're actually using data from the AVSO's exoplanet database to update these transit times, because unfortunately, not all the transit times listed on the NASA Exoplanet Archive are necessarily up to date. Just want to give those 2 quick plugs really quickly and say awesome work to all these Stanford Online High School students. They've truly blown my brain these last few minutes on seeing all the awesome work they've done. So thank you.
Thank you, Rob.
I would second that. This has been a fabulous afternoon. Thank you, guys. Next, we're going to hear from Rick Wasson in new Gaia red and white dwarf binaries near the sun. We'll get Rick turned on here.
The goals of this project were to basically answer 2 questions. Number 1, are there undiscovered binary stars near the sun that contain a red dwarf? And number 2, can I find them and observe them? I data mined the Gaia database, and which is obviously astrometric and photometric, and to some extent spectroscopic satellite. And that access to that database, which is very large, was made very easy by Dave Rowe's software. I chose arbitrarily the solar neighborhood to be anything closer than 100 parsecs. The Gaia satellite does 3-band photometry, basically a wide open luminance type G filter, and then that's roughly divided in half in a blue and red photometric filter. The Gaia HR diagram correlates the color index B minus R with the spectral type, and you can see that class M stars, dwarf stars, begin about 2.3 B minus R. Therefore, anything that's as close as 100 parsecs and has a very red B minus R index must be a red dwarf. I used a 22-inch telescope of the Orange County Astronomers Club. It's located about 15 miles northwest of Mount Palomar, northeast, I'm sorry. And I used a CMOS camera and Sloan filters, and all the processing was done by Dave Rowe's Speckle Toolbox. The plate scale was a little under 1/10 of an arcsecond per pixel. Normal speckle work gives diffraction limited resolution, which for the 22 inch is about 3/10 of an arcsecond for separation of double stars. Most, many short exposures are used, and it's pretty easy to get down to around 11th magnitude for the stars. But the problem for these guys is that most red dwarfs are so faint that even within 100 parsecs, they're out in the 12 to 16 magnitude range, and the late types are even fainter than that. So I compromised and made long non-speckle exposures of 1 second. This is maybe 10 to 40 times longer than typical speckle exposures. The results were that the diffraction limited information is lost from the images, but the resolution of on the order of 1/10 of 1 arc second is still achievable. And this is okay because most of the Gaia targets are greater than 1 arc second separation. The resolution of Gaia is on the order of 6/10 of an arc second at best. Here's an example of what happens after speckle processing. Speckle always uses all of the images. There's no lucky imaging involved or choosing some better than others. All of them have some usable information. The top row shows relatively long speckle exposures of 1/10 of a second. And at left is the power spectrum. This is the average power spectrum after you've Fourier processed each image individually. And that I took 1,000 images, and so the program processes Fourier transforms for each one, then averages them into that kind of representation. The middle program is the typical speckle autocorrelation, which has a primary brightest star in the center and 2 versions of the secondary star. This is not an image. This is a representation of the power spectrum, actually the inverse of the power spectrum. And at right is a reconstructed image, and it is diffraction limited, and it's done by the bispectrum process, which starts with the autocorrelation and does about 10 to 20 times more number crunching after that. And it reveals, if you can see it closely there, a third star in that system. It's about half an arc second from the primary. The second row shows the result of this longer exposure of 1 second, well, many exposures. It shows the same information, and now we're getting down into beyond 14th magnitude. This is an example of a binary red dwarf. They're both similar stars, about 12th magnitude, so they're among the brighter ones, about 50 parsecs out and about 1.2 arc seconds separation. This is an example of a brighter primary and a very faint secondary. The secondary is a late type M star, probably M5 or M6. And those late types just die in brightness really fast. I presume not only because they're cool and small, but because they have so many absorption bands from molecular combinations, not just lines from individual elements. It's easy to see that the Sloan I band is kind of the sweet spot for observing these red stars, because the star is becoming brighter as you go toward the infrared, and the detector, the silicon detector, is still reasonably sensitive. Here's an example of a white dwarf companion. There we go. There we go. Has a very negative blue color index. It's about 14th magnitude, and it shows up best in the Sloan G filter. One more example. There's some indication that some of these have significant motion greater than the error bars between the 4 years of Gaia epoch and when I observed them. And in summary, I observed 35 systems last year. 18 are new, meaning they were not in the Washington Double Star catalog. And the details of this work were published just actually last Monday in a special issue of the Journal of Double Star Observations. So that's the end of my story.
Thank you, Rick. You have any questions?
Yes, we do. Adam Rose asked, where can we obtain the version of Speckle Toolbox 1.13 that allows bispectrum analysis? He has not been able to find it online.
I think you have to request it from the author, Dave Rowe himself. That's the only way I know of that he hands it out. I guess he likes to know who's using it. It's not online that I know of. Dave Rowe is the chief scientific officer of Plane Wave Instruments, so you could probably get through him there through their website.
Thank you. If you have any questions for any of us, go ahead and mail them to, if you want to get in touch with someone. We don't really just like throwing everybody's email addresses around for obvious reasons, but if you make a request, we can pass it along to you. Just send them to Bob Buckheim's email address. I think that's what we agreed on, wasn't it, Bob?
Yeah, that'll be fine. Adam, I will let Dave know that you're looking for that.
Okay, so Jerry, I have no more questions here. You want to go ahead and take it away?
This concludes today's discussion and seminar. We would have a few minutes. We could probably open the whole panel up for questions. We have all the presenters online, and we can individually bring them up. You have a particular question. And this would include the Stella or on the AAVSO.
I have unmuted all the panelists, which means that you can, if panelists have questions for any of today's speakers, feel free to unmute yourself.
Before we get too started, there's been lots of congratulations from lots of people for lots of things. Ken Menzies had queued up a comment that be patient with BFOT. I think that's a good advice. And Richard Stanton says to Gordon and company, it was excellent presentation on the kind of the state of the affairs for the AAVSO membership. And he requested there, different levels of membership, et cetera, 100, 500, each with possible perks of recognition. Your older members might be willing to contribute more if encouraged in this way. What's another kilobuck when you've just bought a 30K camera? I'm still working on buying a kilobuck camera. As I recommended he says, as he recommended in the past, sending out mailed requests to membership renewal might be worth the bother. So those kind of, and one other thing is for the panel to consider, AAS is actively recruiting amateurs. Has there been any discussion with working with organizations or about organizations working together? Again, that was from Gary Cole. The panelists, jump in.
That last one's probably a question for either Gordon or Stella.
I'm muted.
Oh.
I'm muted. Hello.
Gordon, you're good?
I'm muted. Can you hear me?
Yeah.
Yeah, we can.
Oh, okay. I didn't know you could hear me. Two quick answers, partial answers. One, with the various levels of membership, that actually is an active discussion in the plan, and I think it's actually Mr. Buckheim who's coming forward to the board next week as part of the marketing presentation to, and he will bringing that forward as one of the recommendations. So
guilty as charged.
I'm sorry?
Guilty as charged.
Yes, right. And with respect to talking to other organizations, I'm going to say it has begun, but we haven't finished on anything. I've been in contact with Kevin Marvel about working more with AAS. I know Stella's talked with the president of both AAS and ASP when we were at the AAS meeting in January. So Stella, you may want to comment on that. And I know we're talked about working more with the Astronomical League, but no details yet. But yes, we're very open to doing things with the other organizations.
Any questions for any of our other presenters?
Yeah, I have a question, and I can't remember whether it was Nair and Kudley or Perrion and Young showed two light curves for the same star with an exoplanet taken on two different nights, and you saw that one of them gave a really clean transit signature and the other didn't. I'm curious if you see anything else in the data that gives you a clue as to what went wrong on that bad data series. And you should be free to unmute your mics.
I'm not sure if that was us, but if it was, then some of the things we saw were from micro observatory. Many of the sets were problematic just because of the weather on the nights. Some were problematic because of various technical issues, and sometimes there were problems with clouds getting in the way. But those are some of the problems that were the most common for us, and I think were the cause for most of the bad training.
Thank you. That makes sense. When you're looking for a 1% light change, you're sensitive to everything.
So Jerry, my board's clear.
Okay. I think we're done here. I'd like to thank all of the presenters, Gordon and Stella particularly. I'd like to thank the production team. Of course, Bob Buckheim leading it, Bob Gill, Wayne Green, and myself. I'd like to thank all of the attendees. This is what makes SAS and the AAVSO so wonderful, is all of the people that come in and participate in what we're trying to do. Small telescope science is alive and well. Bob, any closing remarks?
Thank you all. Attendance has been wonderful, and we look forward to seeing you tomorrow.
Again, I'd remind you, if you haven't picked out the handouts, get those downloaded. DC Redeemed, Software Bisque, there's some good stuff there.
Yeah, this is Wayne Green. I'd kind of like to throw in my appreciation to Software Bisque for helping support us with developing our observatory out east of Denver. Very patient, very helpful. Thank you again to the great team at Bisque Brothers.
Okay.
I will push the button that turns this all off until tomorrow.
Thank you very much, everybody. Appreciate it.
Thanks.
Thank you.